Hello everyone, welcome to solve this Math Olympiad exponential equation problem, and we have 49 to the power of n plus 119 to the power of n equals to 289 and its whole power n. So that we solve this problem for the values of n, and the very first step we are going to do is here first we divide both of the sides by 49 to the power of n. So we write it as 49 to the power of n. Similarly, we divide this term by 49 to the power of n, as well as we divide this term by 49 to the power of n. So in the next step, you see here these terms are cancelled by each other, and we get here 1 plus, here we combine the exponent of both of these terms and we write it as 119 over 49 to the power of n equals to 289 divided by 49 to the power of n. So similarly, in the next step, we just rewrite these equations as 1 plus, here we write this 119 as 17 times of 7. We know that 17 times of 7 equals to 119, and we know that 49 equals to 7 times of 7 and its whole power n. So this whole equals to 289, and we write this 289 as 7 square, and we write this 49 as, we write 289 as 17 square, and we write this 49 as 7 square and this whole power n. So in the next step, you see here these 7 are cancelled out by the 7, and we have 1 plus 17 over 7 and its whole power n equals to, here we use the nice exponential law, and you know about this law. If we have a to the power of m to the power of n, and if we interchange these two exponents like a to the power of n to the power of m, so both of these cases gives us the same answer, and that is a to the power of m times of n. It means that if we interchange the exponent, if we interchange these exponents, then it cannot factor our final answer. So here we need just only to interchange this exponent, but now first we combine this exponent and we write it as 17 over 7 square and its whole power n. So now we interchange these two exponents and we write it as 17 over 7 to the power of n and its whole square. And in the left hand side we have 1 plus 17 over 7 and its whole power n. So now you see here we have an exponential function in which 17 over 7 be the common expression, so that now we take y equals to 17 over 7 and its whole power n. So we substitute this value in the above equation, so our above exponential equation becomes in quadratic form, and we see that it is 1 plus y equals to y square. So this is quadratic equation but not in standard form. So now first we write this in standard form. So we move this 1 plus y to the right hand side, and it will be written as 1 y squared minus y minus 1 equals to 0. So now in the next step, here, because this is quadratic equation, so here we use this, we solve this quadratic equation by using the quadratic formula. So now first we write the coefficients of this equation, and the coefficients are a equals to 1, b equals to minus 1, and c equals to minus 1. So our quadratic formula will be looks like in this form. It is minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So now we substitute the coefficients value here, and we gives us that minus times the value of b is minus 1, so it will become minus times of minus 1 plus minus square root of minus 1 square plus minus 4 times of 1 into minus 1, and this whole divided by 2 times of a is 1. So after simplification we get here 1 plus minus square root of minus 1 square is plus 1, and sorry, this is the positive sign, and this is the negative sign, and we have this minus times of minus becomes plus 4, and this whole divided by 2. So that here we get the value of y equals to 1 plus minus square root of 1 plus 4 is 5 over 2. So here we have two cases. It's accordingly positive and negative value. So first we write the positive value here, and it is 1 plus square root of 5 over 2, and here we write the negative value, and it is 1 minus square root of 5 over 2. So now we back substitute the value of y, and we know that here we have the value of y is 17 over 7 and its whole power n. So we substitute this value of y here, and we get 17 over 7 and its whole power n equals to 1 plus square root of 5 over 2. Similarly, in this case we have 17 over 7 and its whole power n equals to 1 minus square root of 5 over 2. So that first we focus on the second case, and in this case you see here this expression gives us the negative value, but this is exponential function, and exponential function always gives us the positive value. So we know that an exponential function cannot gives us the negative value, so it is not possible an exponential function equals to some negative value, so that we rejected this case because it is not possible. And now we proceed here this case only, and in this case we have an exponential function equals to positive value. So in order to find the value of n, we need to take the log on both of the sides of this equation. So that here we take log on both of the sides, and we get 17 over 7 and its whole power n equals to log of 1 plus square root of 5 divided by 2. So now we use the property of logarithm. So we move this exponent in the front of this log, and we write it as n times of log 17 over 7 equals to log of 1 plus square root of 5 over 2. So now in the next step, we move this log in the right hand side, and it is written as n equals to log of 1 plus square root of 5 over 2, and this whole divided by log of 17 over 7. So now in the next step here we use the calculator in order to find the value of this log. So after using the calculator, you will finally got the value of n equals to 0.5423. So this is the final value of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.